Year Group 24, and we will introduce our project, Korean Killer, also known as KK. Our primary users are inter-college instructors and teaching assistants managing large discussion-based classes. Although English-only discussion is encouraged, it is difficult to monitor in practice because many students speak at once and voices overlap. As a result, instructors struggle to consistently enforce English-only discussion in real time. To address this, we built a shared real-time classroom support system for inter-college courses. The system detects active speaking through browser-based lip movement analysis and runs directly in the browser without installation. Speaking activity is detected in real time and shared across connected viewers, providing instructors with awareness rather than surveillance. Now, regarding our data journey, we built a dataset focused strictly on realism. For English, we use Korean Accented English from AI Hub to match actual student pronunciation rather than native speakers. For noise, we combine the ESC50 dataset with real inter-college recordings to effectively filter out classroom sounds. Technically, using MFCC and a 2000 millisecond window allowed us to capture the unique prosody of each language, not just keywords. We processed 200 images in Google Colab, analyzing the lip gap and mouth opening ratios. By calculating the mean and standard deviation, we derived an optimal opening threshold of 0.94%. We converted this statistical value into a JavaScript parameter of 1.5 per code. Next is our modern implementation. We applied the optimal lip threshold calculated in Google Colab to our visual detection logic. For the audio component, we utilized Edge Impulse to build a classifier that strictly separates Korean audio from English audio. We use Teachable Machine and Google Colab for lips distance analysis and Edge Impulse for precise audio classification. We deployed the source codes using VS Code and managed version control through GitHub. We then linked our GitHub repository directly to Netlify. This integration enabled continuous deployment. Whenever we push the code base or update to GitHub, the live site was updated immediately. This diagram illustrates our system architecture. On the left, you can see the neural network structure consisting of 1D convolutional layers, which we use for precise audio classification. The flowchart on the right shows the decision process. The system processes the student's face and voice in parallel. The core logic lies in the decision fusion rule. If the system detects Korean sound but the mouth is closed, it filters it out as background noise. A violation is officially triggered only when both conditions are met simultaneously. Korean speech is detected and the mouth is visibly moving. Now, to show you how KK works in a real classroom environment, we will present a short demo video. Please take a look.
This is our website, Korean Killer. Students first join the class by entering their student ID and name. Once the session starts, the camera activates and tracks mouse movement in real time.
The release instances for Korean English. I can first slightly, but I will necessarily proceed.
Now, I'll switch to 한국어 again. 지금부터 다시 한국어로 말하고 있고 아까와 똑같이 의미 없는 말을 계속하고 있습니다. 혹시 주변에 소음이 조금 있어도 제가 말하고 있다는 건 분명하죠. Below, these gauges represent detection sensitivity. They allow instructors to adjust thresholds depending on classroom conditions such as noise level or distance from the camera. Additional controls like mute, dark mode, and full screen are for usability and do not affect detection logic. Now, this is the instructor's view, which is the core of our system. When the instructors click Start Class, the system begins collecting real-time class-level data. These graphs show the number of speaking events, the frequency of Korean usage, and how they change over time. It provides a shared, real-time overview of classroom behavior and helping instructors notice patterns without interrupting the class. Multiple devices can share their lifestyles simultaneously, making it suitable for large inter-college classrooms. When the class ends, clicking Stop Class shows a summary of results, and the session can be reset for the next class.
Our system achieved over 90% accuracy in detecting active speaking under frontal-face conditions. It also operates with real-time latency under 100 milliseconds. By acquiring visual mouth movement together with audio cues, we were able to significantly reduce false positives, meaning background noise alone does not trigger detection. Finally, the system is privacy preserving as it does not store identities or recordings, only real-time speaking status. These are our most impressive errors. First, Korean speech was sometimes misdetected as noise because our initial audio features were insufficient. We solved this by changing pre-processing methods. Second, English spoken by Korean users was also misclassified due to accent differences, so we replaced the English training data with Korean accented English speech. In conclusion, our project demonstrates that a real-time privacy-first AI system can effectively support inter-college instructors without disrupting classroom flow. For future work, we plan to improve robustness to head and ghost masks and occlusions, better distinguish speaking from actions like yawning or reading, and further strengthen multimodal confirmation for larger and noisier classrooms. Thank you for listening to our presentation.